Hello, my name is Roger Watson and I'm going to explain as simply as possible what an item response function is. In an earlier session we met the item characteristic curve, which describes the relationship between the score on an individual item and the underlying latent trait. In this session we're going to look at the item step response functions. Clearly you'll get the idea that these are related to the item characteristic curve. Please note that the item characteristic curve is sometimes described as the item response function, so you can see this relationship in the terminology. However, here I'm going to describe the overall relationship between the score on an item and the latent trait as the item characteristic curve, and what I'm going to describe now are the item step response functions. Item step response functions, or ISRFs for short, describe the relationship between the change in score between two responses to an item and the latent trait. Clearly, the ISRFs are analogous to an item characteristic curve. Please note that item step response functions only apply to polytomous items. For dichotomous items, item step response functions and item characteristic curves are analogous. So imagine a polytomous item with three responses: yes, unsure, and no. Clearly there are three responses, but there are two item steps here. There's one step between yes and unsure. Here I've marked it in red. And there's a second step between unsure and no, which I've marked here in green. So I've labelled them here step 1 and step 2 in their respective colours. Next, let's think what these steps would look like if they were plotted on the graph in front of us. I'll leave the item characteristic curve there in black and plot the item step response functions in red and green to show you. Please note that in the present example, no means more of the latent trait than yes. So drawn here in red is what item step 1 between the response yes and unsure might look like. So what do you think the step 2 will look like, given that it represents more of the latent trait? In other words, it represents more difficulty. Step 2 will look something like this in green. It will be further along the latent trait than step 1 because it represents more difficulty. And please note that the item characteristic curve, represented in black, lies somewhere between the item step response functions. So what we've learned here is that an item characteristic curve is broken down into several item step response functions, and you may already have worked out that for n responses there will be n minus 1 item step response functions. In this example there were three responses: yes, unsure and no, and two item steps. However, if we had an item with 5 responses, for example strongly agree, agree, unsure, disagree and strongly disagree, we would have 4 item step response functions. Please also note that item step response functions should not intersect. If they do intersect, that violates the model of double monotonicity, which we've already met earlier in the session, and that means that the item steps are no good and therefore that the item is no good. So note that item step response functions must not only be monotonely homogeneous like the item characteristic curve, they mustn't intersect. Thank you very much for listening.